Okay, so this video is about the programming assignment 2 peer evaluation. I'll talk about the evaluation criteria and show you my solution to this programming assignment. So for grading the coding for programming assignment 2, you're looking at the game 1 file, and the evaluation criteria are these two things: follows the coding standards and uses an appropriate implementation approach, which doesn't have to exactly match my solution, but there shouldn't be a lot of extra code, there shouldn't be lots of extra variables. Use your judgment a little bit here. One extra variable does not mean you have to take off a point, but 5 extra variables for 5 draw rectangles, for example, for each of the sprites, would mean you definitely take off points for that, a point for that. So there's been some confusion about these 2 points, no more than minor problems. So perfect is definitely no more than minor problems. I was just trying to make sure that a couple of minor glitches don't matter in the grading. They still get full credit. And so that's grading the coding stuff. Grading the video, a file should be attached, but if a file is not attached, in fact, I say you're required to attach a file to try to help out people who can't get an anonymous account on YouTube or don't want to, or have YouTube blocked or whatever. It really doesn't matter. If there's a file attached, that's great. We got it set up to support that. If you've added a link to a video somewhere, that's fine too. Either approach is perfectly fine for submitting videos. And I said that in the announcement when I talked about videos. So you have to look at the video and potentially the source code for these criteria. So there should be 5 different sprites in the load content, and you're going to have to look at the source code for that. The sprite should be drawn actual size, and you'll need to look at the source code for that to confirm it. Randomly picking one of 5 sprites, it would be great if all 5 appear in the video, and then you're sure. But sometimes with random numbers, that's hard to get. So if it doesn't seem obvious that all 5 are in the video, just go look at the source code and make sure the next method on the rand object was called properly. The sprite image should change approximately every second. Sometimes we're going to generate a random number that picks the same sprite that's currently being displayed, and that's okay. That's just a side effect of random numbers, but around every second you should be seeing the sprite change. The sprite location should also change around every second. And so, the different sprites that get shown every second will appear to move around the screen. And sprites should never be partially outside the window. So that's the grading criteria. Let's go take a look at the solution itself. So I've added 5 different content items here. These are just sprites from the programming party game. And I added 5 sprite variables here at the top of my code. And it doesn't matter if you call those sprite 0 through sprite 4. That's kind of an intuitive approach for this particular problem. But it's okay if you called them, building 0 through building 4. You could have called them Asian building and church and house and teepee and tower. Sprite 0 through 4 is perfectly acceptable for naming conventions. This is code I gave you, so something keeps track of the current sprite, and there's a single draw rectangle that we're going to use in the code. So going to load content, one of the things you have to do is load the content, so that's what's happening here. Here's the first place, you had to add the load content here, but here's a place where you need to make sure that current sprite is initialized to one of the 5 sprites that you have. And so I just set current sprite equal to sprite 0. I just started at the 0th sprite. This is the important one for one of those points, right? Rand.next returns a number based on the number you provide here, but this is, if you only provide one, this is an exclusive upper bound. If you chose the next overload that you provide 2 arguments to, the lower bound and the upper bound, this would be 0, 5. So this generates a random number between 0 and 4. And the way you find that out is you read the documentation for the random class and you look up the next method and you see how it deals with the argument you provide to it. So in this is the code that you go through and make sure that if you pick a 0, you set the current sprite to your 0th sprite. If you pick a 1, you set it to your first sprite, and so on. Next, you go here and you set the X location of the draw rectangle, so this will pick a random place horizontally. You pick the X location for the draw rectangle based on the preferred back buffer width minus the current sprite width. Now a couple comments here. If you used window width here instead, that's fine. There should be no point loss for using the constant here rather than the preferred back buffer width. I note this comment here, I'll slide over. I know I said between 0 and the preferred back buffer width minus the width of the current sprite, but it's okay if you just use the constant. That is acceptable. By the way, this does not slam the sprite all the way up to the right hand side ever. Think about it. If we have an 800 pixel wide window and a 799 pixel size current sprite, 800 minus 799 is 1, but rand.next has an exclusive upper bound, so this would only generate a 0 for us. So if we really wanted to make sure we got all the way to the right, this would actually be graphics preferred back buffer width minus current sprite width plus 1. And then sometimes we would slam the picture up against the right hand side. In terms of the requirements of the program, this way will work. It will keep all the sprites totally inside the window as I required, but it never will. There'll be a buffer, sorry, bad word. There'll be a space of 1 pixel on the right where we never actually end up with a sprite up against the right hand side. Meets the requirements of the program and made it easier for me to, well, clearly except for people who thought that this minus was a hyphen, sorry about that confusion, but to clearly tell you what you needed to do here without saying, and by the way, add 1. Okay, you do the same thing for Y. So these lines of code make sure that we're keeping that we're randomly generating a location that keeps the sprite totally inside the window. And notice I can use current sprite width and current sprite height here because just above I assigned them already based on the random number. So current sprite at this point is holding the sprite I'm going to be drawing. Okay, what a horrible typo right there, but we want the draw rectangle to draw the sprite's actual size, and there's a point associated with this. We need to make sure that the draw rectangle width is set to the current sprite width, and the draw rectangle height is set to the current sprite height. And we need to do that every time because our sprites might be different sizes, and so if we've picked a new sprite, we need to make sure the draw rectangle will draw it at the appropriate size. That's it for the update method. The only other thing we need to do is down here, we want to draw the current sprite, which we set in the update method, and we want to use the draw rectangle that we adjusted its properties up here, right? We changed the X for the draw rectangle here, we changed the Y for the draw rectangle here, and we changed the width and height for the draw rectangle here. So now we can just use that draw rectangle and draw using white, which this is not a requirement. If people want to like change this color and tint it magenta or whatever, that's perfectly acceptable, no point loss. It would be a point loss if somebody is creating a new rectangle every time here in the draw method. That's horribly inefficient, and we already have done the work to make sure the draw rectangle is correct by the time we get here. So that would be a point deduction in the code part. In the implementation, let me find paint.net again, in the follows an appropriate implementation approach, that would be a solid, they should lose a point because that's a really, really bad thing to do. It generates a new draw rectangle 60 times a second. And so that would be a really poor implementation choice. So there you go. That's my programming assignment to solution and a discussion of how the grading criteria should be applied.